Okay, so here's our notes for today. We already filled in the warm-up by going back to our notes from last class to decide what the A and the H and the K do. We have 3 new parent functions to look at today. Last class, we looked at the quadratic and the square root and the rational. Today we're looking at exponential, logarithmic, and cube root. Bless you.
Thank you.
You will probably remember from last unit that exponential has a horizontal asymptote. And it has arrows. I don't think we talked about logarithms in depth yet. We talked about them once. Logarithms have a vertical asymptote and arrows. And then the cube root function just has arrows. That right here, these are the equations for the parent functions. And I want you to add to your graphs. This is 2 to the x, this is log x, and this is cube root of x.
Wait, are those the parent function?
So take a minute to make sure you filled in what I have, and then we're going to turn the page.
Yeah, please. It's like our picture time.
All right. Something important to know is that exponential and logarithmic functions are inverses of each other. Make sure you're on page 2 and you wrote that down. Inverse functions undo each other, like multiplication undoes division, right? And addition undoes subtraction. So when they are inverses, they undo each other. When they have the same base. You'll learn more about that not next unit, but when we study logarithms in depth. But you'll notice that exponential functions and logarithms kind of look alike, except that exponential functions have a horizontal asymptote. That's controlled by k, and if the k is positive, then the asymptote will go up, and if k is negative, the asymptote will go down. So we're going to graph this function, and we're going to graph it looking at our parent function that's on the front. On the front, notice that your asymptote starts at y equals 0, but we have to shift it up 3. So you're going to draw your asymptote shifted up 3. Now we need some points on our graph, so I'm going to go back and find some points that I can shift up 3. I'm going to use this point here, bless you, at 0, 1. And then I'm going to use this point here at 1, 2. You see that? 0, 1, and 1, 2. These are the points that I'm going to shift up 3.
Where did you get those from?
This is my parent graph right here. And so I looked at my parent graph and I found 2 points to help me draw the curve. We're going to use those though. We're going to use 0, 1, and 1, 2. Okay, so going back, here's 0, 1. I need to shift it up 3. So I'm going to go 1, 2, 3. And then the other one was at 1, 2, is here. I'm going to shift it up 3. 1, 2, 3. And then you're going to draw the curve that goes through those 2 points. Now, some of you may have started the Delta Math assignment that's in there for you, but if you hadn't, you're going to be doing that for homework tonight. And it has parent functions, and all you're going to have to do is shift them or stretch them, whatever it says to do, okay? But you'll have to get your points in the right place. So you need to use the parent function points, and then you're going to stretch in this case. So I had 0, 1, and when I shifted that up 3, it became 0, 4. I had 1, 2, and when I shifted it up 3, it became 1, 5. So logarithms do not have a horizontal asymptote. They're going to have a vertical asymptote. And that's going to be controlled by the h value. Now remember, when we did the parabola, in the parentheses, x plus 5 did not shift to the right. It shifted which direction? Left. Excellent. So that means it's going to shift left 5. And so we're going to take that asymptote that was at 0, and we're going to go left 5 to x equals negative 5. See that there? X equals negative 5. Now, if you are ready ahead of everybody else, you can go back and find 2 points on your logarithm that we can shift. Thanks. Can you make your asymptote? Thank you. All right, so you moved your asymptote left 5. Now I'm going to go back to the parent function, the logarithm function, right here. And the 2 points I'm going to use are right here at 1, 0. And then the other one I want to use is actually at 10, 1. It's right here at 10, 1. So 1, 0 and 10, 1. Those are the points I'm going to use. I'm going to transform them left 5. One, 0, 10, 1. Okay. Yes.
Are the points just any two?
It kind of matters because you want to make sure that you get the shape. So I am going to suggest some that are like really in the center of the shape for you. Okay. If you use 2 different points, it's possible to still do it correctly. All right, 1, 0. I'm going to take 1, 0 and shift it left 5, and I'm here at negative 4, 0. All right, 10, 1. So if I go to 10, 1, which is kind of off my graph, but I go left 5, I'm going to end up at 5, 1. So I'm going to use that point. Now, when I do this, I'm not going to just make a straight line between them because I need to keep the shape of the logarithm graph. So the logarithm graph, it's curved, and then it's kind of like an L shape. It makes a turn like that. Okay, so make sure you're drawing a graph that looks like a logarithm graph. I'm leaving that up there for another 30 seconds, and then I'm turning the page. Here we go. So we're going to graph this exponential function. You could use a table of values if you want. If you do use a table of values, you need to go grab the calculator because we're not doing Desmos, okay? So you could use the table of values and substitute these values in to get the y's, or you can go back to the parent function and find the transformation and do that. We're also going to review graph characteristics from our other quiz, so we need to go over those as well. And then here we have a logarithm. So take a moment, please, and try to graph these 2 U-try problems, and then try to do their graph characteristics. All right, so this is 6 here. Now, this is one way to get the points 0, 5, and 1, 6, which is not a whole lot, but there are some other things we can do as well. The other way to get these points is to take the 2 points from our parent function. So that from our parent function, we had 0, 1, and 1, 2. And we have to shift them up 4. So 0, 1, if I shift it up 4, it gets me the 0, 5. And then 1, 2, if I shift it up 4, it gets me to 1, 6. But here's the important thing. My asymptote was at 0. So if I move it up 4, my asymptote is going to be at y equals what? 4, yeah. If I go 0 and I go up 4, then I'm going to have an asymptote at y equals 4. And where it says asymptote equation, that's it, y equals 4.
Where do you get the plus 4?
Uh-huh.
Is that what?
Right, so this shifted us up 4. I'm going to draw in the shape because I'm going to take it from the front. Okay, look at the front. This is exponential, and so this is the shape of my graph. I'm going to copy that shape. So now that we have the graph, I want you to work on domain, range, and intercepts. If you're done with that, then work on the practice 2 problem. The domain and the range. Your domain starts all the way on the left at negative infinity, and it goes all the way to the right to positive infinity. So that is your domain. Your range starts right after this asymptote. So you have an asymptote at y equals 4. So your range starts right after 4. We're not going to include it, so we're going to use parentheses.
Why isn't it included?
Because we can't ever touch the asymptote. So it's going to get closer and closer to the asymptote, but we can't get there. Okay, your x-intercept. Remember, don't just write 5. You're going to write the point 5, 0 for your x-intercept.
Wait.
Oops, that's not my x-intercept. That's my y-intercept, right? Thank you, Nala. My y-intercept is 5, 0. What's my x-intercept? None, right? None. Okay. More of you need to correct me when I make a mistake. Everybody makes mistakes, right? So if I make a mistake, it's for the whole class's benefit if you let me know. So your y-intercept is 0, 5, because 5 is the y part of it. All right, so now that we've done it right twice, are we ready? Are you guys have any questions on that? Okay. All right, next problem. This is a logarithm problem. So we're going to graph it. I'm going to show you how to do this in the calculator if you haven't done it yet. So we're going to go to your calculator, and you're going to press log. And I need to do -3. Remember the negative buttons down here. Plus 4. And then close your parentheses. And I got 0. And then I'm going to put that on my paper. Okay? And then I'm going to do the next one. So log, and this time it's 6 plus 4. And I get 1. So I can graph those points -3, 0 and 6, 1. And then this time the plus 4 shifts me which direction? Remember, it looks like it should be right, but it's actually what? Left. Yeah, left, right is a tricky one. So I'm transforming by shifting left 4. So my asymptote that was at x equals 0, sorry, it just went out of focus. My asymptote that was at x equals 0, it shifts left 4, so it's going to be at x equals -4. Now we have to look back and see what was the shape of the logarithm function. So from page 1 of your notes, the logarithm has this shape here, and so I'm going to draw it in. So your domain starts right after the asymptote at -4. So it starts here, and then it goes all the way to the right, which is what? It's infinity. Good. So -4 to infinity. Do I include the -4? No, because there's an asymptote. So make sure you have parentheses. All right, my range starts at the bottom, which is what? It's -infinity. And then it goes up, and I can see it's going to the right, but because I don't have a horizontal asymptote, it will keep going up, even though it's going up slowly. So it's going to keep going up to what? Infinity. Good. All right, the x-intercept is -3, 0. For the y-intercept, I'm not going to estimate it because there is a method for finding the exact y-intercept, but the algebra of it is beyond us at the moment because we haven't learned more about logarithms. So I'm just not going to ask you the y-intercept. I don't want to put an inaccurate answer down, but I also am not prepared to teach you about logarithms in that much depth today. So we're just not going to answer that one. Okay? All right. Questions on your logarithm? Next page.
I'm fine. It's just my nose is like.
All right, so make sure you've marked these 3 points on your parent function because those are the 3 points we're going to be transforming. -1, -1, 0, 0, and 1, 1. Notice they kind of line up on a straight line, but we're not going to draw a straight line. We're going to draw this cube root function. Okay, so when we shift right 3 and up 4, I'm going to start with my inflection point. It's going to go right 3, and then it's going to go up 4, and then it's going to be located at 3, 4. Okay? So 0, 0 went to 3, 4. We'll do -1, -1. So -1, -1 is here. I'm going to shift it right 3 and up 4, and it's right here at 2, 3.
Can you move the paper down a little?
Yeah, sorry. So -1, -1 shifted right 3 and up 4, and we ended up at 2, 3. Then 1, 1. I'm going to shift it right 3 and then up 4. I'll be right there at 4, 5. Now, like I said, the points look like a straight line, but you can't draw a straight line. That's not the shape of the cube root function. So the cube root function, you start at your inflection point and you're going to draw like the rainbow like that. And then you're going to draw the upside down rainbow like that. All right, this last practice problem, I'm going to give you a little bit of advice on. We're going to name the transformations first. Okay, so inside we have x plus 3. That's the one that acts backwards of what you think. It's going to move it which direction? Left. Good. So we're going to shift left 3. And then the -2 shifts us which direction? It would be right if it was underneath the root because that's kind of like your parentheses, but since it's outside, it's going to be down. So it's outside. This here is acting like the parentheses, so this one is going to move it down 2. Okay, so those are my shifts. What does the 3 in front do? You guys remember what the 3 in front does? You're on the right track, right? So the 3 in front is going to pull it up, make it taller. No, you were definitely on the right track. All right, so it's going to be a vertical stretch of 3. Now, the inflection point is only going to shift because when you multiply this 0 by 3, you still have 0. So the stretch does not apply to the inflection point. So I'm going to move my 0 left 3 and down 2. Okay? So 0, 0. It went to -3, -2. Left 3 and down 2. Okay. My stretch is of 3. So here's one way of thinking about it. Usually, you see how the points up here are over 1 and up 1? That stretch of 3 is going to make me go over 1 and up 1, 2, 3. And then here it's left 1 and down 1. It's going to go left 1, but it's going to go down 3. That's probably the easiest way to think about the stretch. So first, we shifted the 0, 0 to find our inflection point. Then we applied the stretch from there. So we went over 1, up 3, back 1, and down 3. And you still are going to draw the shape of the cube root function. So draw it always in 2 pieces. Start at the inflection point, make that rainbow, and then start at the inflection point and make the upside down rainbow. All right, so over here it asks for the inflection point, and that one we said was -3, -2, because I went left 3 and down 2. And for the cube root function, domain and range is easy because you have those arrows that are pointing down and up and left and right. So they're both going to be negative infinity to what? To infinity.